Okay, so today we're looking at Pascal's triangle. Now, some of you may have seen Pascal's triangle if you've taken 4U data. Sometimes they introduce some 3U data as well. Pascal's triangle is a mathematical triangle that's built by adding the items above. Okay, so our very first line, we put a 1 on top. And then what happens, to make the number under, we add the two numbers that are here. Now, in this case, we only have a 1 here. There's nothing over here. This is like an imaginary 0, so it equals 1. And this will equal 1 because of the same thing. Then, the next line is 1, 2, 1, because 1 plus 1 is 2. 1 plus 0 is 1. And then 1 plus 0 here is 1. Now, if you can imagine, the next line is going to be 1, 3, 3, 1. So we have 1 on the outside there. 1 on the outside here. Come from here and here. 2 plus 1 is 3. 2 plus 1 is 3. And 1 plus 0 is 1. And the next line is going to be 1, 4, 6, 4, 1. Erase all my purple lines here real quick. So, what happens is this mathematical triangle that is built as such. Move this over. So I have more room to build it. Okay. Now this goes for infinitely long. So I have 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, and 1. Let's go one more line. 1, 8, 28, 56, 70, 56, 28, 8, 1. Okay. So a couple of things to notice here about Pascal's triangle. One, it's symmetrical. So if I draw a line through the middle here, you can see it's symmetrical because on each side are equals. On this side it's 1, 1, 1, 1 here. And on this side there's a 3 on one side, 1 and a 1. There's 4 on each side, a 1 and a 1. 10 on each side, a 5 on each side, and a 1 and a 1. And so on and so forth. Sometimes we have one that's equal there. That does have a partner because it's straight down the middle. Okay? So notice it's symmetrical. That's one of the main points here. There's also really other cool things that happen with it is if we're going sideways, the sum sideways is the same as 2 to the power 0 for the first row. The second row is 2 to the power 1, which is 2. Third row, 2 to the power 2, which is 4, which 1 plus 2 plus 1 is 4. Third one is 2 to the power 3, which equals 8. 3 plus 3 plus 1 plus 1 is 8. If we keep going this way, it keeps going up by 2 to the power of. That's going to be 16. Right, 10 plus 6, 16, and it keeps going and going. So the sum is 2 to the power 5, 2 to the power 6, 2 to the power 7. So those are all kind of neat things you can see here. And I'm just pointing out neat things. Those are not going to matter for what we're doing here. But other cool pattern is I call it the hockey stick pattern, where if you go down at any point you stop and go sideways, 1 plus 2 plus 3 equals 6. If I go this way, if I go all the way down here, 1 plus 4 is 5, 15, 35, boom. And it continues on. Anything you want to go there, that equals. These are just cool little patterns that exist. And if you look here, this is just going up by 1, 2, 3, 4, 5, 6, 7, 8, this way and this way, going up by 1s. This is going up by 2s, then 3s, then 4s, then 5s, and 6s. and so on and so forth. Okay, so the neat thing that we want to pay attention to here in terms of data is a phenomenon that exists here, that if we consider this columns and rows, so if this is row 0, row 1, row 2 going that way, and we go this way with column 0, column 1, column 2, column 3 going this way, a pretty cool thing happens. Okay, so if you look here, row 0, column 0 is 1, and 0C0 also equals 1. Now if we go to row 1, column 0, so row 1, column 0, so we're kind of going here, rows and columns. If we plug that in our calculator, we get 1. And row 1, column 1 is also equal to 1. So these two match. This matches this and this. Now if we go a little bit further, we do this line here. This would be row 2, column 0. That equals 1. Row 2, column 1. That actually equals 2. And row 2, column 2 equals 1. And we keep going from there. Oh, sorry, my son's calling me as I make my video. Give me 2 seconds. So what happens here is that Pascal's triangle could be written as a combination. So if I rewrite Pascal's triangle as a combination, this matches, this would be 3C0, 3C1, 3C2, and 3C3. And if I go down one more, 4C0 equals this part. 4C1 is this number right here, 4C1, 4C2, 4C2, 4C3, 4C3, okay, and 4C4. Okay, so no matter where you go, you can rewrite Pascal's triangle as combinations. And you can see it's down here. Now these ones here, what I've told you before, 0 over 0. Let's not take that one. Let's take this one here. 5, 3. Why the hell did I do that? 5, 3 is the same as saying 5C3. Okay? So, what's really neat here is 2 things. Number 1 is the fact that these match. Okay? The fact that, for lack of a better word, let's go 5C2 matches Pascal's triangle. Now, if we remember, this is row 0, 1, 2, 3, 4, 5. And this is column 0 going this way. So it was 0, 1, 2, 3, 4, 5. So 5C2 is going to be right here. Okay. So if I go to my calculator and go 5C2, I'm going to get 10, which is right there. Okay. So, as we know before, where's my 5C2? 5C2 is right here, 5C2 is right here. So let's highlight them both. Now, if I was looking just at my Pascal's triangle, I know that this plus this, with 2 things above equal the thing below, which is the same here. So what equals 5C2? 5C2 equals the 2 above it. 4C1 plus 4C2 equals 5C2. And I can predict this all the way through. If I go, let's do 7C5. Here's 7C5 right here. So what's going to equal 7C5 is 6C5, plus 6C4. Okay, and the way I remember it is, let's go back to 7C5. 7C5 equals, you go one lower on the rows, 6C, and you keep the higher one, keep this number the same, and you add on one before it. Okay, so if I was doing 3C2, what's equal to 3C2? Well, what's equal to 3C2? I go one lower, 2C2. I keep it exactly the same here. These numbers are the same, and I go one lower. Plus, I need to go one lower here, which is 2C1. Which, if we look here, here's our spot, 3C2 right here. 2C2 and 2C1 is equal to it. Okay? So this is the first part of what we're doing here. The other cool thing is, remember how I said it's symmetrical? Okay? Let's do a couple of these questions first. If I were to ask you, what is equal to 6C2? What two things are equal to 6C2? Well, we go up a row, which would be 5. We keep the second number the same, we keep the column number the same, 2, plus 5C1. Which, if we take a look here, makes sense. 6C2 is here. So these two numbers are going to lead into it, just as if, here's 6 right here, 0, 1, 2, right? 15 is made by 5 plus 10. Okay, and 5C1 is right there. So let's do another one. What would happen if I said 7C5? What equals that? Oh, I already did that one right there. Let's do 8C6. What equals 8C6? Well, what equals 8C6 is, and if I'm going to write 8C6 here, is go up a row, 7C6 plus 7C5. Those two right there. And I could go, what's equal 100C50? See if you can get that one as well. Same pattern. Because we know 100C50 is equal to two things right above. And the one on this side here is going to have the same, we're going to go back a row, 50 plus 99C49. And that's going to be our equal to there. So that's the very first thing I want you to take away. Not the first thing, because knowing that Pascal's triangle matches combinations is the most important thing. The other thing I said was how this is symmetrical, right? How this here is symmetrical. But what's really cool here is how you can figure out which combinations equal to which. Because if we take a look here, let's go to this one, right here. Let's go to this one, this will be super easy. So 4 and a 4 on this side. Now if you look here, this would be 4C1, 4C0, 4C1, 4C2, 4C3, 4C4. That's what that line would look like. Now if I told you 4C1 equals 4C3, okay, take a look and see if you can connect these numbers here. Connect those numbers, okay? Let's do another one here. Let's do 5. Let's do this one and this one. So this right here is going to be 5C0, 5C1, 5C2, 5C3. Okay. So 5C2 equals 5. Oops. 5C3. How can I connect these two numbers? See if you can find the pattern for me. So what's the similarity between 1 and 3 when associated with 4? And what's the similarity between 2 and 3 when associated with 5? Right? Let's do 6 and see if we can figure that one out here. Let's do this one. So that's going to be 6C0, 6C1, 6C2, 6C3, 6C4, 6C5. So I have 6C1 equals 6C5. Now, if you haven't seen it already, the way I figure out which one is equal, well, my first one's 6C1. To find its partner, I go 6 minus 1 equals 5. So the partner is going to be 6C5. If you look up here, 5 minus 2 equals 3. And our partner was 5C3. Up here, 4 minus 1 equals 3. Okay, and then my partner is 4C3. So I can make a prediction here. If I said 7C2, what's equal to 7C2? Well, I'm going to go 7 minus 2 equals 5. So 7C5 is equal to it. So if I go to 7 here, I should be able to figure this out. That's 7C0, 7C1, 7C2, 7C3, 7C4, 7C5. So 7C2 is right here, 21. If I go to 7C5, boom, they're equal. So if I were to predict 9C5, what's equal to 9C5? 9 minus 5 equals 4. So 9C4. 7, 8, 9. So it's going to be 0, 1, 2, 3, 4, 5. So 9C4 is equal to 9C5, which makes sense. Now, the one thing you do have, you have these guys in the middle every so often. But if you think about it like that, that's 8. 8C0, 8C1, 8C2, 8C3, 8C4. If you think about it, if I have 8C4, what's equal to 8C4? What's 8 minus 4 equals 4. So it's 8C4. That's why some of them in the middle don't have a mirror image or symmetrical number because it's right in the middle. And it's mirror itself. Okay? So that's the first thing I want you to take away. Three things. One, how to make Pascal's triangle. I make Pascal's triangle by adding the things above. So this is 1. 1 plus 1 is 2. 1 plus 0 is 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. And so on and so forth. Now, I could give you a question on a test that looks like this, where I go with maybe 1,000, maybe 500. I give you a blank. I give you 20. I write the number 420 here. I go like so, and I go like so. And I ask you to fill in these numbers here. Okay, and you have to kind of figure out, okay, it's Pascal's triangle reasoning, 1,000 plus 500 is 1,500. I can't do this one, but I know that these two numbers equal 420. So that's going to be 400. That's what plus, and then we go 900 here. That's number one. Number two, recognize that I can rewrite Pascal's triangle as a combination. Where we use the rows 2C1, 2C0, 3C0, 3C1, 3C2, 3C3. Where we use the rows starting at 0 and the column starting at 0 as our first number and second last number in our combinations. Now, with this being said, our number that adds up to it, if I have 4C3, the numbers that add up to it, 4C3 is going to be here, is one row shorter, 3C. It's going to be the same number plus row above and one number below in terms of columns. Okay? That's number 2. Is that number 3? I guess number 2. Then the last thing here is know that it's symmetrical and that we can find each number's partner by minusing off the column from the rows. So if I ask what's equal to 7C2, you can go 7 minus 2 equals 5. And what's going to be equal to it is 7C5. If we go back to my thing here, 7C2 equals 7C5. Those two are equal. Okay? Understand like 9C3 equals 9C, 6 minus 3 equals 6. And those two are going to be equal. Where's my 6? Here's my 6. 6, 5, 4. Oh, yeah, 3. Gotta go one more back. That's it. Oh, I'm in the wrong column. That's why. I'm here. I should be here and here. I was in the 10s down here. Okay, 9C3 equals 9C6. Okay. So those are the 3 things you should understand. So that's going to be your first set of homework questions, is understanding that. Okay, so I'm going to stop the video here. First set of homework questions deal with this.